Good morning. Now this is class 9 of our chapter digital filters. Now today we will talk about the realization of digital filters, direct form 1 realization and direct form 2 realization. Now this is actually the exact uh, of class 8. That is, in class 8 we have discussed about direct form 1 and direct form 2 structures in a brief way. Now in class 9 we are explaining the same thing, exactly the same thing, but in an elaborate way, or the same concept is explained. Okay, now from exam point of view, if this direct form 1 realization and direct form 2 realization is very important, so if it is asked like an essay question, then you can refer class 9, or if it is asked for a short answer type question, then you can refer the same topic from class 8, because class 9 is exactly the same as that of class 8 but explained in an elaborate way. Okay, so let us begin the session. Digital filters are basically discrete time, linear time invariant systems. Now these discrete time systems can be either FIR or IIR. Now these systems are described by difference equations. Now there are various ways of implementing or representing these difference equations. Now this process of representing the difference equations or the various ways of implementing the difference equations is called by the name realization of digital filter structures. Now you can implement it either using hardware structures or by using software structures. Okay, that is, we can each of these systems are described by difference equations. These difference equations can be represented or they can be implemented either using hardware or software techniques. That is, there are various ways of implementing or representing these difference equations. Now this process of representing or implementing the difference equations in various ways is called by the name realization of digital filter structures. Now there are two types of structures. That is, if the number of delays involved in the structure is exactly the same as the order of the difference equation, or if it is of the same order as that of the transfer function, then it is a canonic form realization. Now if the number of delays involved is not the same as the order of difference equation or order of transfer function, then it is called by the name non-canonic realization. Now this is a describing equation or the general difference equation for a linear time invariant system, that is given by equation 1. Now taking Z transform, we will get this. Now as already said in class 8, we know the transfer function or the system function h of z is given by y of z by x of z. So from this equation, that is from here, we can say that the transfer function or the difference function of an IAR system, this is a general form, is represented by h of z is equal to this one by this. So in class 8 we have already said that this one numerator is actually h1z, or it represents the zeros of hz, or it is an all zero system, and this one is called by the name h2z, and it actually represents the poles of hz, or it is an all pole system. So this is actually the general equation for the system function or transfer function of an IAR system, and it is expressed as a ratio of two polynomials in z raised to minus 1. Now these equations, it can be implemented in a number of ways. So we know that there are various elementary blocks to implement discrete time systems. This one also we have studied in class 8. See, adder, you have given x1 and x2n, you are adding plus sign, so output will be y of n equal to x of x1n plus x2 of n. Now constant multiplier x of n is multiplied with a constant a to get output y of n as a into x of n. Now secant multiplier, you have got x1 and x2 and it is multiplied into sign, so output y of n will be x1n into x2n. Now delay element x of n, it is passed through the delay element z raised to minus 1, so output will be y of n will be x of n minus 1. Now if it is a general term, so that is, it can be either z raised to minus 1, minus 2, minus 3, like that. If it is z raised to minus k, then output y of n will be x of n minus k. Now time advanced elements x of n is passed through z, so output y of n will be x of n plus 1. If it is a general term z raised to k, then output y of n will be x of n plus k. So z raised to minus 1 represents delay element and simple z represents the advanced element. This also we have studied in class 8. So there are different types of realization structures. So realization actually means implementation or representation. Okay. So equation 1 and 2 are arranged in different formats, and so we will get different structures. Now if we have got a single equation, that single equation is broken, or if it is split into small equations. Later these small equations are simplified. Later these simplified small equations are joined or connected, or they are cascaded to get the final or overall system realization. So similarly we can have various structures like different direct form structure, cascade form structure, parallel form structure, etc. Now in today's class we will learn about the direct form structure for IAR systems. In that we will deal with direct form 1 realization today. Direct form 2 realization we will deal with in the next class. This also the same equations I have already taught you in class 8. So this is actually, we know this is a general equation for the system function or transfer function of an IAR system. Here this numerator actually represents h1z, and this one, that is 1 by 1 plus this particular term, actually represents h2z. So h of z can be written as h1z into h2z. Now as I already said, here the overall IAR system is realized by connecting or joining or cascading these two functions, h1z and h2z. So here the numerator h1z actually represents zeros of hz, or it is an all zero system, whereas h2z represents poles of hz, it is an all pole system. So this is the general equation for the transfer function or system function of an IAR system. Here h1z is called, it actually represents the zeros of hz, or it is called all zero system, whereas this one h2z, this is h1z, and whereas this one is h2z. h2z actually represents the poles of hz, or it is an all pole system. Now we are going to derive or prepare the direct form structures of h1z and h2z. See, h1z, this we have already seen, that is a time domain representation of h1z, the numerator part. We also know that h1z is equal to y1z by x1z. So y1z will be h1z into x1z. So you have to just multiply each of these terms of h1z with the x1 of z, then you will get this equation. Now you are taking the inverse Z transform on LHS and RHS. So inverse Z transform of y1z will be y1 of n. Now what is the inverse Z transform of the first term? b0 is kept as such. Is inverse Z transform of x1 of z will be x1 of n. Now consider the second term. Take the inverse Z transform of b1 z raised to minus 1 x1 z. b1 is kept as such. See here, the inverse Z transform of x1z is actually x1 of n, but in this case you have a delay element z raised to minus 1. So what will be the answer? x1 of n minus 1. That is why you are getting x1 of n minus 1. Similarly, apply inverse Z transform to each of these terms. So you will get the equation 7. Now the figure that is shown here is actually the realization of the numerator part h1z. Okay. Now let us consider the other part, h2z. We know, we have already seen that h2z is given like this. h2z is nothing but y2 of z by x2 of z. So just replace x1, x2 of z with this equation and then write this as such. Then finally you will get the expression for y2z as this, and the time domain representation will be like this. Now take the inverse Z transform. So inverse Z transform of y2z will be y2 of n. Minus is kept as such, a1 is kept as such, y2 of z, the inverse Z transform of y2 of z will be y2 of n minus y2 of n, but since there is a delay element, it will be y2 of n minus 1. Similarly, you take the inverse Z transform of each of these terms in this equation, so you will get this equation. Now this figure is actually the realization of h2z. So you have got realization of h1z and the figure for the realization of h2z. Now if you want to get the final or the overall realization, what do you have to do? You have to connect or join or cascade H1Z and H2Z, just a block diagram, and this is the figure. So this is the overall realization of direct form 1 structure or direct form 1 realization. So direct form 1 realization is obtained by joining or connecting or cascading cascading realization of H1Z and the realization of H2Z. So this figure is exactly the same as that we have seen above, and that is of H1Z. This is exactly of that of H2Z, that is each of these figures we have drawn individually, right? This is realization of H1Z. Now this figure is a realization of H2Z. These two figures are just connected together, the same figures, to get the overall direct form 1 realization. Okay, now this particular structure actually requires m plus n plus 1 multiplications, m plus n additions, and m plus n plus 1 memory location. So that's all about direct form 1 realization. This is exactly the same as that of class 8, but if it is asked like an essay question, definitely you have to write from class 9. Okay, now direct form 2 realization we will learn in the next class. Okay, thank you.